You are officially on record, so
store rating.
stick with me.
You can turn off the dash and store.
Now, you are the most important person in this class right now.
You want me to be quiet?
You are the special. Yes. Right here.
Everything I just said.
They will hear everything. All right, here we go. This is actually page 10 and 11, not page 8 and 9. I will give you 8 and 9, and I think in 2/3 of my classes, I forgot to tell you that we are not testing on Friday. I don't know if this is one of them, but we are not testing on Friday. Yes. Sometime after Friday. It won't be Monday because we won't be here. It won't be Tuesday either. Probably won't even be Wednesday. So I'm wasting an entire week of stuff for you because I love you.
Thank you.
Every single one of you, I have some emotion towards you.
Why are you looking at me?
Okay. Today, like when you go home and your parents are like, what did you learn about today? You tell them you learned about stoichiometry. Stoichiometry, that's what you're learning today. The word's harder to spell than this entire process is itself. Okay? Stoichiometry, an example of it, just listen to everything I say today and you'll be fine. Stoichiometry, here's an example. It will say if you have 50 grams of chocolate chips, how many grams of cookies can you make? Now that is weird to us because we usually have bags of chocolate chips and we usually just have cookies that we make. But could we mass the bag? Yes, we use one of these, hence the visual aid. Could we mass what a cookie weighs? Yeah. It's not hard at all. But in order to do it, you have to know the recipe to make the cookies, don't you? You need to know the ratio of chocolate chips to cookies. And our example there is you have to be able to balance the equation in order to find out what the recipe is. So you can go from one thing to another. Now today, every equation we do, I hope you can balance it, but I will balance it for you. It's not super difficult. Here we go. The first reaction, it's actually a representation of something that's not chemistry, but it'll be all right. You have Fr, which is not francium, just go with me here, plus W goes to FRW2. Now, this is representing something in your life. This right here is representing a bike. What do you think a FR represents then? Frame. I went in a weird order there, sorry. A frame plus wheel makes a bike. But wait a minute, this isn't balanced. How would you balance this reaction? There's two W's right here. Though we're not using a unicycle, the word says bike. There's two W's right here, so you must have two W's over there, and one and one. Can everyone understand this balanced representation of a reaction? One frame, and yes, whoever said it, there's more stuff to it. Just zip it. One frame plus two wheels equals one frame, two wheel. Or a bike, which is a lot easier way to call it. All right? That's not impossible to understand, is it? All right? Neither is today. Because today, we're going to take this type of thing and say, well, all right, so now instead of one frame, what if I told you you had 5? How many bikes could you make? 5. And how many wheels would you need? 10. All we're going to do today is balance a reaction. Then I'm going to give you a different number, and then you're going to tell me the other two numbers. It's not rocket science. It's not even 3rd grade math. Okay, maybe it's 3rd grade math. But it's below whatever my kid's doing in school, and he's in 4th grade. All right. Now, eventually, it gets a little bit trickier. Because in chemistry, this thing doesn't measure in what we call moles, and we'll get there. it measures in grams. So it would be strange, but it would be like, I would say, that sounded like a teenager talking right there, but whatever. Instead of just saying you have 5 frames, I'd say you had 50 kilograms of frames. How many bikes can you make? That doesn't work that way. First off, I didn't ask for kilograms of bikes. Don't laugh at him. All right? So, now, don't get lost right now. This is just an example, but in order to know how many bikes I can make, I would need to know the mass of a wheel. Wouldn't I? Let's say the mass of a wheel was 2 kilograms. So this really means I have how many wheels? 25 of them. Which means I can make how many bikes? Oh, I start with frames, I'm sorry. Which means I can make how many bikes? 25. Yes, Wade.
So the 2 kilograms is about the frame.
Yeah, I switched what I was talking about. It's all frames. I'm sorry. I just ruined everything. I'm going to delete this video already. All right. This is what we're going to do. We're going to apply chemistry to it. But don't panic. A couple other things right here. Anytime I say the word moles, it might as well be a 4-letter word to some of you. You're like, I don't get it. I created this slide for last hour. It says something like, moles is equal to a big A number. That's what mole is. It's not something to be scared of, unless it's cancerous, but that's a whole different story here. A mole represents a number that the world is too lazy to write out. It's this number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It's that number. Now, really, there's a 2 right there, but who cares? Who wants to write that number every time? Nobody does. So we would write it in scientific notation. So if we were writing out a balanced chemical reaction in reality, it would be something like that. That was a sweet box. But no one wants to write that. So instead of writing that big A number, we write these small numbers. Okay, now, one last thing before we get started. It's the same thing, but I just want to rewrite it. Na plus Cl2 goes to NaCl. Not balanced, so I need a 2 right here, and a 2 right there, and a 1 right there. Okay? Now, these numbers, this whole time we've been working, and we've been calling these things coefficients. They are coefficients, but coefficients are representing the amount of moles in the chemical reaction. So what this is saying is you need 2 moles of sodium for every 1 mole of Cl2, and you can produce 2 moles of NaCl. And if I want to compare just 2, now there's 3 things up there, but I can compare any 2 that I want, and I can get their relationship to each other. So for instance, I could say for every 2 NAs, I have 2 NaCls. That's easy. What if I got crazy up in here and I said I have 4 NAs? How many NaCls would there be? 4. Because these numbers are the same number, right? Let's get super complicated. Let's say I have 2 NAs, like over here. How many Cl2s are there? There's 1. That's my ratio from one to another. Well, what if I have 10 NAs? How many Cl2s? 5. All right? I just find these ratios, and I can do whatever I want to them as long as I do it the same to both sides. That's just math, right? And we've waited a while for math. There's no if, ands, or buts in math. It just is. 2 times 2 is 4. We know that. Not under certain pressures, certain temperatures, certain concentrations, and when you feel like it. It's always 4. So finally, we're doing something in chemistry that most people don't hate. Now, you don't love math, most of you, but it's super not that bad, I promise you, if you stick with me. Now look, everything we do today is super easy. You could have a negative 0.5 GPA and figure out what we're doing today. Okay? I'm not saying that for anyone specific. It's easy. And you will honestly, if you're above a 1.5, you'll be offended on how slow I go and how stupid it seems. But you need to learn this process while it's easy so that when this is hard, it isn't. Okay? What we're going to do today, that's a pretty good looking set of stairs right there. Today, we're going to go from 0 up to the first stair. And it's not hard. Most of you can do that math in your head. But the problem is most of you have no idea how to go from here to there in your head. But if today I can move you from here to there, and then tomorrow I move you from here to there, and then Friday I move you to there. If you please will do what I tell you, you will be great. Okay? I have to break it down into simpler parts. Every part of your growing up life, you did something that was easy before you did the same thing that was harder. Don't just skip steps. Just trust me for once. Are we ready? Page 10 has an equation on it. And if this very first part confuses you, it doesn't matter. As long as you can do the last part, that's all that matters. All right, 2s plus 3O2 goes to 2SO3. That is a balanced chemical reaction already written out for you. Good enough? All right, now, there are some note blanks here, and I want you to underthink them for once. Like, don't think that they're complicated questions. They are not supposed to be. So here we go. Remember, the numbers are the coefficients that represent the moles, and they relate to each other. So here we go. The first one says, if 2 atoms of S are used, how many molecules of SO3 could you make? 2. Please look right now. Do you notice that the number of S's is the same as the number of SO3s? So I could put whatever number in the universe right there, and it would be the same one right there. We can do that. All right, so next, if 2 dozen atoms of S are used, how many dozen molecules of SO3 can be made? 2. That's weird. It's almost like they're the same number. Who thought the answer was 24? Okay, well, 2 dozen is 24, but sometimes people yell out 24 and then we mock them. By the way, isn't dozen just a word that means a number? Does that mean you panic at the donuts when you see the word dozen? And you're like, oh shiz, I can't do this. I don't know what that word means. It means a number. Thank you. Today we decided to be silent day, so you'll fit right in. Okay? So by the way, all I'm saying is when I give you a problem and the word moles is in there, don't quit. You can do it. Gosh dang. Thank you. All right, here we go. This one's super hard. The next one. If 1 mole of S is used, how many moles of SO3 could be made? 1. Okay, that wasn't very hard.
The next one is hard.
Right, Sierra? That wasn't hard. The next one, it has the word moles in it. I can't do this. If 3 moles of O2 are used, how many moles of SO3 can be made?
0.
3. Well, how? I'll show you. Look right here. Look at the problem. It says if 3 moles of O2. What's this number right here? 3. It already is 3. So whatever the question asks next will be the same as whatever is right there. Okay? It doesn't equal 3. It equals whatever's already written.
So 2 moles.
So 2 is the answer. No, sorry, I said this wrong.
Yeah, it was.
No, it was 2. Don't listen to me. It was 2.
Okay.
I'm an idiot. But when you look as good as me, it doesn't even matter. People just are like, oh, I don't care. He's good looking. So I can't read the problem. Let me do that again. That went super not well. Savannah, don't quit. Okay.
Don't give up, Savannah.
You put your hands in your face. Sorry. Here we go. Let me reread that. I feel a little bit of guilt. You all had it right, and I told you were all wrong, and now you don't know what I'm talking about. If 3 moles, I just read the problem backwards. If 3 are there, you can make 2, right? In my head, I had 2 making 3. That's all I did. Okay, now, by using moles and molar proportions found in a balanced chemical equation, we can predict the amounts of chemicals in a reaction. Okay, so this is what a chemist really does. They need to make whatever amount of whatever they're doing, and they need to know how much they need for it. That's all. All right? It's not super hard. Very good. So here we go. What are the molar proportions given in the equation above? Now, molar proportions sounds weird, but it's just these things. These are the moles. Their proportions just means it's written out as a fraction. It's very simple to find these. It says blank moles of S. All you do, look at the screen, all you do is find the number in front of S, and it is a 2. On the bottom it says moles of what? O2. So I find that number. It's a 3. I literally just look in front, and then I go from there. Try those other 2 real fast. Who's done? Sweet, you're all awesome individuals. So the middle one, that is just 2 over 2. Who had that? Okay. You feeling it? You're like, I could do this all day. The far right one, you should have 2/3. Who had that? Okay. Now, if it's 2/3, now 2 divided by 3 in math is different than 3 divided by 2. We know that. But the relationship of one to the other is the same whether I say 1 or not. Meaning, I have 3 sisters, but my 3 sisters could say they have 1 brother. It doesn't care which way we define it. All right, it works out both ways, and we know what we're talking about. So just like here, there's 2. Uh-oh, I got the wrong end. There's 2 of these to 3 of those, or 3 of those to 2 of those. So it's okay whichever way I flip it. Are you all right with that? Okay. Before we move on, I want to review one thing, and that is these steps. Get ready to roll your eyes. To the picket fence. It hates you too. All right. Okay. First off, the picket fence. Look, smart kid, you didn't have me teach it to you. I promise you it is not that bad. Cole, are you awake? Okay, good. All right. So the first thing to a picket fence, just to review, and look, it's America. If you want to hate them, do it. You can. That's what we do. It's what we're best at. But it would be better for you if you just say, hey, I've learned it before. It was a little bit hard, but I'm learning it again. It'll be a lot easier. All right. So you always start here with the given. Do you remember that? Oh, you do this to me. Are you kidding me? Okay, never mind. All right. You start in the top left with your given every time, right? Then, what comes down here every single time? The same thing. I should put unit. Someone pointed out to me today in my AP class that by using my ands are exactly the same. I'm over it. All right. Over here, you always have an answer. All right. What always goes here? The unit of the answer. Now, when we put stuff in here, it'll make more sense. But none of that seemed like the hardest thing we've done all year, right? This is way easier than telling me whether the solubility of a negative heat of solution increases or decreases in hot or cold water. Remember those? Like, I don't even teach that in AP. It's a waste of time. But the state makes me teach you. I don't torture you on purpose. The state does. All right. We're going to go to some notes, and we're going to be awesome individuals. Learn it my way while it's easy, so it's easy when it's hard. I'm teaching you the best way, I promise. So here we go. We have what we call conversions examples. And this is where chemistry really finally happens. This is what your parents do if they are chemical engineers. Any chemical engineering parents? One? No wonder you guys are all awesome, I mean. All right, so here we go. First off, balance that equation in the middle of page 10. Bless you. Balance the equation in the middle of page 10 under A. It says, like you can balance it before I write it out, Polly. Who has it already balanced? Raise your hands. Okay, thank you. Let's do this. Where would you start? I would start with a 3, personally. How come not this 4? It's part of a polyatomic ion. Like, you can, but you'll be wasting your time. All right, so 3 SO4s, put a 3 right here. That makes how many coppers? 3. All right. Now, I'm not done. How many aluminums? 2. So I put a 2, and then I leave that as a 1. Who had that right? Nice job, Flash. We can all do this. All right, now maybe you did it. I gave you the answer so far. Stick with me. Now, I know the notes are there, but follow me, and then we'll fill them in at the end. This has been read for a while. I'm tired. Oh, it went back to black. Okay, good. Here we go. All right. So reading the problem, it reads, if you have 6 moles of aluminum, how many moles of copper can be made? I know that there's plenty of people in here that could do that math in probably under 10 seconds. But please do it the long way so that it's easy. I can't stress enough how important it is to learn this process one step at a time instead of trying to jump to the top of the stairs. Here we go. What do you always start with here? The thing I gave you. Now you need to be specific. The more you write, the less you'll be wrong. I promise this time. So it gave me 6 moles of what? Al. You need to write the whole thing. I know it's a lot of work, but it will help you a lot in the long run. If you don't put this, then you don't know what goes down. If you don't know what goes down, then you're in a lot of trouble. All right, now, the picket fans, whatever is here always goes down there. Tell your lab partner right there.
Whatever is here always goes down there.
Thank you. All right, now, are we ready? So, do I put 6 moles of aluminum down there? No, I only put what? The unit. Moles of aluminum. Sorry, I switched colors if that bugs you. All right, moles of aluminum. Now, what am I solving for? Moles of copper. This unit of the answer always is the unit of the last one on top. Moles, Cu. Now, look at the screen. This isn't very difficult. The numbers that go here, are the numbers that you have right here. So a 2 went in front of aluminum, and a 3 went in front of copper. And then mathematically, what do we do when we have these things lined up? Times across the top. Now I'm going to say it tricky. Times across the top, times across the bottom, and divide by both answers. Now this one's not hard because there's only 1 on the bottom. So 6 times 3 is 18, divided by 2 equals 9. Yeah. The 6 came from the problem. Is everyone okay that the 6 was in the problem? I will always give you a given. Your job is always to get rid of it. How are we getting rid of the given? It's right here. Look right here. How am I getting rid of the thing I gave you?
You're dividing it by 6.
I divide by it. That's why this half arrow, whatever, that's why this always goes there. Because I don't want this, I want that. So, to get rid of something you don't want, you got to divide by it. All right, now, we talked about this term, but let's make sure we understand this term. This thing right here, this is extremely important, and it's called the ratio of coefficients. And I usually shorthand it because I never really do know if I spell coefficients right. That's why I do all that. Usually, if I refer to the ratio of coefficients, I put R/C. I don't know. That's what I mean if I write that. That means ratio of coefficients. Okay? The ratio of coefficients. Please look at the screen. I don't know why I'm not explaining that, but whatever. The ratio of coefficients is always where I go from what I was given to what I want. We have to do this every single time. Now, if this comes from the balanced chemical equation, then it must be pretty important that we balance our chemical equations. All right? Now, most of the math on your test, I give you the reaction already balanced. Because I'm going to give you test questions that ask whether you know how to balance. And I'm going to give you test questions that know if you know how to do math, that tell me if you know how. If you mix them, I don't know which place you're failing. Does that make sense? So don't panic here. All right, turn to what?
Oh, smart.
It is smart, and we don't say it very often, but every teacher will grade that way to try and figure out where the real problem is. All right, now turn to page probably 13 or 14. And we're going to do an example from your homework. You guys are being amazing right now. Even you. Oh, sorry. I thought you were looking for some
Mr. Moore,
prompts.
one time we had to give Mr. Rollins the highlight.
I didn't. Mr. Burt almost did. But then Rollins coughed out the fry on his own and caught it in the middle of the air. It was an amazing day. All right. In the middle of page 14, it says mole to mole. Now, this is like the 10th time I'll say this. This first problem is super simple, and you can do it in your head. But I want you to do it the long way to get good at the long way. So here we go. The first thing to do is balance that. I'm 100% sure you can balance this one. It's in the middle of page 14. It says N2 plus O2 goes to NO. Spend about 10 seconds thinking through how to balance this one. All right, 2 N's, 2 O's. Feels like there should be a 2 right there to me. 1, 1, 2. We had that one. Right. Sweet. Okay. I'm sorry. I didn't mean to set false expectations. I mean, that one was super hard. If anybody got that right, I'd be surprised. Is that better? Oh, okay. Okay, so moving on. What does the problem give you? Number and unit. What does it say? If you have 5 moles of what? Oxygen. What does it want you to solve for? thank you, moles of nitrogen monoxide. And that might give you a heart attack. You're like, I don't know what nitrogen monoxide is. But look, does this look like nitrogen and oxygen on the left? Together, I mean? No. Which one? Whoa, no pun intended. Does this look like a nitrogen and an oxide together? Yeah, so when in doubt, just brainicize it. Made that up. No moles. That's what we're looking for. Whoa. Why did I put it there? I'm just a nerd. And I just spit everywhere.
I just erased it.
It doesn't matter. Moles, no. All right, now, what unit goes down here every single time?
Moles.
Whatever was right there. So I write moles of O2. What unit do I always want right here? The answer. So moles of no. I come up here. What's in front of no? 2. What's in front of O2? A 1. 5 times 2. We can do that because we have 10 fingers. That's 10. Rocket science. Look how far we've come. Right? I swear my lunch was spiked or something. I feel weird. All right. Let's skip the next problem because it's easy, and let me help you with the harder problem. You with me? It says octane is burned in a diesel, or not a diesel, in an internal combustion engine, yada, yada, yada. Who cares? What did he just do?
It looked like you were filming your cups. I was on the camera right there. So
It's just frozen.
I was looking at
I was gonna see if I could put my hand in it and then see if it moved or something.
You're going to put your hand in my drink.
No.
Oh, I see. Cronin coming at you. Davis. Everyone right here, close your eyes. This could poke your eye out for life.
Oh.
That's how the first one was supposed to go. All right, here we go. C8H18. That's all I really care about in that whole problem. There's a lot more, but for balancing, does anyone, are you with me enough to know what type of reaction that is besides you? No. It's a combustion. Still love you, though. You're great. It's a combustion reaction. Whoops. What am I doing? What?
Said you needed to throw a football.
I remember that day. It's one of my best throws in my whole life. All right.
Well, I heard you say it, but I just knew what happened.
What do you? I was just reenacting.
Wait, where are we?
No one was supposed to look at me. We're in your homework.
Oh, we're still in
Still in homework. I'm on the third one down. Is nobody with me?
With me?
It's on the third one down.
Wait.
39.
Oh, okay.
Yeah, we're on 39.
Looking for the.
It's a combustion reaction, so what number do you start with?
Uh,
A 2.
Oh. Then what?
And do the carbon?
Oh.
Yeah, do it backwards today. You're not trying. You're looking at me funny. Waiting is not trying.
I already tried.
Start with a 2.
I already tried.
Do you have a 25 in your answer? Does anyone have a 25 in their answer?
oh, we're supposed to.
Yeah, do it. It's wrong. Just joking.
Oh, yeah, I have one.
Yeah, you do. Come on, Joe. Blanchard, I mean. You have 25?
Yeah, I think I have
Oh.
Dude, I don't got a 25. What? You did it wrong.
Are you serious?
Okay, no. Come on, Joe. Okay, you start with 2, right? Now start with 16. Then H. So H 18. 18 over here by H. I mean 18 ups.
You're student.
Your rules. You know you're doing it. I didn't notice that was okay. So there's 18 right now. 32 because 18. Because 16 is first two.
What's the roll
Then you add that 32 plus 18.
I'm going to teach everybody my rule again.
Wait, I can do it. I can do it.
I know you can.
Just give me a sec.
Yeah.
I'm going to teach everybody.
That makes sense. Thank you, Joe. Now we have to do
I didn't get a 25 in my answer.
All right, here we
I
go.
got a decimal in my answer.
You got a decimal.
I know. Shut up.
Go back. My turn to be rude, not yours. All right, now look. I need everybody. You can do these. I promise. You just follow the 4 steps. I can see the glazed eyes. There's like 4 of you. I know when you checked out. And when you 4 check out, I know there's probably 10 others that I can't read faces. I'm extremely observant.
The glazed.
I know what's going on in your brains sometimes. Don't quit. 2, because I told you to. It's on the yellow paper. It's on page 12. It says, hey, on a combustion reaction, start with a 2. The next step, go ahead. What are you doing? All right. The next step is to balance carbon. Putting a 2 here made 16 carbons, right? So you got to put a 16 right there.
Can't have those.
The next step, it just says to take the number with H and put it in front of water. So you just put an 18 right there. Don't think, just do.
I did that.
Then, good, you're on fire.
How do you get a 25?
Just watch. 16 times 2 is what number?
32.
32 plus 18 times 1 is how many? 18. If I add those together, I get 50.
Oh.
If I put a 50 right here,
I
though,
knew my touch.
I get 100. So I divide 50 in half. Now look, even if you struggled there, please do the picket fence. You can do it. At least setting it up shouldn't be very hard, I hope. You're doing the picket fence. You're just reading that sentence and putting it in there. It's 1,200. That's 2,400. And divide by 2. What are you looking for? Carbon dioxide is just. Okay, who was at least able to accurately set it up? Raise your hands. Okay, besides the balancing, we can ignore that. I know that's still a struggle for a lot of you. This was it? Take the number I gave you, the unit I gave you. Take the unit I gave you, put it on the bottom. Find the number that goes with it. Put the unit I want on the top. Put the number from there. Now, I'm going to be a tree hugger for 30 seconds. This is real math. This is gasoline right here. Someone with a calculator, take this number right here and times it by 22.4. $26,880. All right, that's the amount of liters of carbon dioxide your car emits in one trip to Salt Lake City. From here. That's more gas than is in this room. How many cars are traveling between here and Salt Lake every day? A ton. And this is estimating a car. Add the trucks, like unbelievable amount of carbon dioxide. Get out of my room.
Flashback to fifth grade when my teacher made me sit in the back too, so bad.